Thank you, Samuel. Now for the second presentation, we'll have a presentation by Richard Baham on a strategy for the development of metrology to enhance the sustainment of the seismic and infrasound components of the IMS network. Please, Richard.
Okay, good afternoon, everybody. So yes, I'm going to talk about some of the metrology developments that are intended to enhance the sustainment of the seismoacoustic components of the IMS network. Are we aligned? I'm just thinking excuse me a moment, we've gone too fast. There we are. So, all of this fits within the quality assurance work, actually. So quality assurance has been developed alongside the establishment of the IMS network over some years. And you can see here on the right of the screen some of the quality assurance goals that we've set for operating the IMS network. So in fact, if we can achieve the top one of those goals, which is our kind of ultimate objective, then we're in a position where we're strengthening technically the capability and scientifically the capability through having transparency, with taking on board benchmarking, recognition of best practices and so on, and even engaging in peer review processes. So all of these QA activities really strengthen the value of the IMS data. And the range of initiatives that we're looking at are so diverse, and the number of stakeholders and stakeholder groups that we need to engage with is also quite diverse. So I'm guessing that most of you in the audience can identify with at least one of the stakeholder groups shown here. So for these reasons, it's very important to have a strategy for these quality assurance activities so that we can coordinate the tasks effectively, we can give visibility to what's being undertaken, and we can prioritize. So really the strategy is more of a working plan that can be followed to develop these various initiatives. These strategies take the form of roadmaps. So you can see here the kind of the incarnation of the roadmaps at various stages. So we've got high-level objectives, we've got detailed activity plans, and then text documents supporting the real detail of what those plans involve. So we're developing these roadmaps for both infrasound and for seismic technologies. And really the idea is not just technological advancement, but many of the aspects are also targeting streamlining of activities across the IMS, looking at operational efficiencies, and all of these kind of things are in line with the new sustainment strategy for the IMS to basically streamline and improve efficiency. And we've recognised now that state-of-the-art metrology has a key role to play in these sustainment goals. It's in many cases, which we'll see, metrology is driving these technical developments that we want to put in place. And the rest of my presentation really is just looking at some examples from the strategy. It's not the complete strategy presentation, but these are some of the priorities and highlights from that strategy. And the first one is field calibration of sensors. And this is something that spans all technologies. But here on the slide, we're looking particularly at seismometer systems. And the needs here are that we need to have traceability, measurement traceability, so it links with the SI. We need to have low enough measurement uncertainty so that any changes can be resolved and not hidden by the uncertainty of the calibration methods. The methods need to be straightforward. We can't really have complicated measurements implemented in the field. And ideally they should have minimal or zero impact on normal operations. We don't want to interrupt the key monitoring activity simply to make routine calibrations. So the idea of them is that they can identify system faults and trends in behaviour and so on. And of course the whole thing needs to be economically viable. So some of the actions we've got here on the plan is to look at current activities, what's currently done within the IMS and in parent networks, and then have a steering and monitoring role to look at the research on potential alternative methods. And have a proper critique of those methods, existing methods and potential new methods, we can look at the benefits and limitations of those. And then what we really need to do is formulate new R&D goals to properly evaluate potential new methods. The second aspect I've focused on here is of measurement traceability. Samuel nicely described the need for measurement traceability and what benefits it brings. And here the need is to have a good dialogue with the national measurement institutes that are responsible for effectively maintaining the top-level primary standards. The needs also for pilot studies and comparisons, which is a good way of collaboratively developing the technology, but also benchmarking your capabilities at certain points in time. And we need procedures for transferring measurement traceability from the laboratory to the field with travelling sensors, for example. So the activities here is to maintain a liaison with the BIPM Consultative Committee. This is the kind of top-level forum for metrology in this field of acoustics and vibration and hydroacoustics. And this has been very fruitful in the past. With them, we need to formulate mutually beneficial pilot studies and comparisons to validate measurement capability of the key performance parameters for sensor systems that we're talking about. And where possible, we need to look at whether IMS calibration methods are consistent with protocols defined in international standards. So this is another layer for transparency and accountability of methods. Okay, so the final experimental type thing I want to talk about is that of installing seismometers and setting up the orientation correctly. This needs to be rapid, but at the same time technically rigorous. And at the moment, this is quite a time-consuming aspect of station establishment. What's really necessary here is an autonomous method that can be implemented under PTS full control. Right now it requires a dialogue with manufacturers at the time of installation, and given that there may be different time zones at play, this can actually be quite a cumbersome, time-consuming process. So what's really needed here is a systematic, streamlined process with the necessary input from metrology to get that alignment done correctly at the time of installation. So again, we're looking at a streamlining of practice. So the actions here are pretty much like before. Look at what's currently done, conduct some research on optimum methods, and look at the metrology input necessary to get proper validation of the alignment with all the necessary traceability and so on, and then develop software tools that make this a more streamlined job in practice. Okay, so those were some practical aspects. Excuse me. The other aspect of the roadmap is the whole idea of communication with the stakeholders. As we saw at the beginning, there are several stakeholder groups, and each of those need a slightly different approach to the way PTS communicate with those and engage with them. So for service providers, for example, what we'd really like to do is drive research on measurement capability and characterizing sensors, particularly with regard to the long-term or life cycle expectations for sensors deployed in the field. So this is really looking at their susceptibility to the environment and so on, trying to predict what the lifetime of a sensor may be and trying to estimate whether the sensor can fulfill the life cycle expectations that's growing actually through the sustainment program. And then with manufacturers, I think it's very important here to communicate clearly the quality assurance initiative to make sure that it's fully understood, where the requirements are understood, but they're also consistent with what the manufacturer might expect to be in place when they engage with PTS. Obviously, we can't make it extremely onerous that actually it becomes too difficult for the manufacturers to comply with, but at the same time, PTS have certain requirements on them that the supply of sensors and systems needs to be done within a quality regime. And then finally, by talking to manufacturers, we've got a way of keeping abreast with the latest developments, seeing what's coming online, what might be the sensors of the future. And what we really need to do here is agree on a way of having those discussions, whether that can be done in an open forum or whether it needs to be on a one-to-one basis. But whatever it is, we need to do it on a fairly regular basis to agree what the next steps are and stay in touch with these different stakeholder groups. It's also a way of disseminating the strategy and keeping the strategy up to date And then once we've achieved some things, we can actually communicate those achievements back through case studies and so on to look at the benefits of the QA initiatives on the various activities, whether that's installing sensors or type approving or actually procuring sensors. Okay, and then the next layer of dialogue is with the network and station operators. So here it's necessary to understand what current QA activities are in place, what calibration practices look like, and understand the underlying rationale for whatever those practices are. And then at the same time, we can disseminate the PTS technical requirements for sensor systems and for data integrity, understanding that the PTS role is more of a forensic role rather than a simple monitoring role, which brings certain QA requirements with it. And then hopefully we can find some kind of common ground where the benefits of QA are nicely understood, best practices can be disseminated, and try and get some consistency across different parts of the network in what's actually done in practice. So again, this is a kind of review and respond type activity. So look at how, for example, field calibration is done in different places, come up with a critique of those methods, look at the limitations and the advantages of different approaches, and then put all of that together to look at new ways of doing field calibration, taking the best of existing practices and maybe doing some research on new methods and so on. And also using data coming from the measurement systems to try and analyse how well that system is performing in situ, whether there are any signs of early onset of trends or changes in response and so on. So really getting into the troubleshooting and failure analysis mode to try and keep the sensors operating, but also understand when and why failure occurs. Okay, so last but not least, it sounds, the documentation side of all of this sounds a very dry topic, but actually when you get into it, it reveals lots and lots of interesting aspects, particularly when you start discussing it with the stakeholders and having a review process. You really learn a lot from trying to write down what you do in practice. But the point of documenting everything is to try and give some level of continuity to practices so that the best practices are written down and preserved for future generations to pick up and use or to modify for the better. So actually it's just a way of marking best practices, what's currently done, and having clarity on how the requirements of the operational manual are implemented in real life. So we're working through a whole series of documents to try and capture best practices. It seems like a never-ending task. It's a completely iterative process. As we make one draft, there are some new inputs to capture. So it's interesting in that sense that it's very engaging and very interactive. But we're also expanding the range of documents now to cover things like validation of stations or revalidation of stations, trying to capture equipment life cycle performance and so on. So the range of documents as well as the depth of the documents are expanding. And all of this takes us towards that goal of having continued practice and not losing best practices by staff leaving the system, leaving the organisations and so on. We want to try and capture it all for future use. Okay, so I should say that these roadmaps are designed to be living documents. They're not something we're going to write and put aside for 3 years and try and follow it. The idea is to review them regularly with stakeholders and to take account of progress, technical progress made, changing landscape for these activities, changing priorities, and trying to integrate emerging external developments as well. So we expect to review the roadmaps at least annually to keep them up to date. And this will be supported by a technology horizon scanning activity where we try and keep track of latest developments in the different fields. And we'll do this through participating in conferences like this one, systematic review of scientific literature to capture what's coming along, and market surveys for developments in instrumentation. Okay, so just finally, these technology roadmaps have been invaluable already in directing research and development during the establishment phase of the IMS, particularly with regard to infrasound technology. They represent a clear and preemptive strategy for seismoacoustic technology that remains really essential for delivering the wider IMS ambitions as we enter the era of sustainment. So thank you.
Thank you very much, Richard. We have time for a couple of questions from the audience. Yes, Thomas. There is. Yeah.
You talked about standardization and the international scope. Are there already standardization initiatives in infrasound underway currently? Do you know of some?
Yes, for the international standards. Well, we already have a standard for low-frequency calibration of sensors. This was something we put in place during the last infra AEV project that you were involved with. So yes, we've documented calibration methods for infrasound using piston phone devices, for example.
Is that applicable to field calibration?
Not so much, no. This is really starting the change. This is a way of deriving primary standards from first principles. I guess we could look at then methods of transferring calibration to the field as another method, but that's more of a method standard rather than a calibration specification standard. But that certainly wouldn't be off the agenda. We could look at how that might work.
Maybe you have one more.
Thanks. Yeah, hi, Birger Steen from Northstar. I was wondering, in the sort of larger tech community, there's a practice of users, customers, sort of banding together in user forums and user groups, and that's a quite efficient way to gather stakeholder interests in having a conversation with vendors. Is that something you've considered in this context?
It is, yes. So one of the stakeholder groups was the general user and scientific community. And we did think hard about how to engage with those. And we are thinking about some kind of web-based forum, discussion forum, or actually whether we can piggyback on something that exists already. Just start some new threads up in existing forums could be another way to go. But yes, we're certainly thinking of that. Apologise for my hand, I've got a bright light shining in my eyes.
Thank you.
Thanks.
Any other question? Okay, I think. Thank you, Richard.
Thank you.